Hi, Geometry. Welcome to in a little section. So I can use a formula for the number of permutations, and I can find the number of possible arrangements. This is for a subset out of how many. So here we go. Yes, you see the answers here because I did this whole video and then I realized it didn't record. I don't know if that was my fault or what, but let's carry on. So I'll try to go slow. You might have to pause it because I'm not writing, but warm up. So there are 8 soccer teams in your district and 7 teams in a neighboring district. How many teams can you match up for games? So this is what I was calling the multiplication method. So if you want to know how many different matchups, you just multiply them. So 8 times 7 equals, there's 56 different games or matchups. All right, how about this one? This one can be a different, 2 different answers depending on how you look at it. A padlock has 3 numbers and uses 3 of them in a sequence to open a lock. If you randomly choose 3 numbers, what is the probability that you choose the correct sequence? Well, you have 9 choices for the first number, 9 choices for the second, and 9 choices for the third. So that's 9 to the third power, which is equal to 729. However, what if you can't reuse a number? So you'd have 9 choices for the first, then 8, then 7. So that's 504. Looks like an S. So this is if you can't reuse a number. And this is going to introduce our topic. All right, so here are some counting methods. First of all, the tree diagram, a method of listing your outcomes of an experiment consisting of a series of activities. So we've done this, except for this can take up a lot of space. The multiplication of choices, if there are n possible outcomes for one event, such as 8 soccer teams in your district, and m possible outcomes for another event, such as 7 teams in the other district, then there are n times m. You just multiply them. Okay, so we've done that also. Now, permutation is an arrangement of objects in which an order is important. Basically, you're arranging a subset. Arrange a subset. So that's what we're going to focus on a lot. And then we also have factorial notation. So n factorial doesn't mean n. It means n times 1 less times 2 less. Keep going down until you hit to 1. One thing I want to specify is 0 factorial. That's equal to 1, so I want you to know that. So how you work it out? 5 factorial means 5 times 1 less times another 1 less times another 1 until you get down to 1, which is 120. I just got a text from JD. Oh, I'll tell you about it later. 7 factorial is 7 times 6, 5, 4, 3, 2, 1, which is 50, 40. Of course, there's an easy way to do this on the calculator. So on the calculator, and I'm trying to do it here, but of course, with this LED screen, you can't really see it. So I want 5 factorial, okay? So I'm going to press a 5. Okay, there's the 5. And then I'm going to press math. I'm going to go over to probability, and then do you see number 4? There's an exclamation point. Go down to number 4, press enter. 5 factorial, it's really hard to see that. Press enter, 120. All right, so for the calculator, press math, or 5, math, go over to probability, go down to number 4, enter. All right, so let's look at example 1. This is an example of the multiplication method. You have 4 types of bread, 2 types of cheese, and 5 types of meat. How many different types of sandwiches can you make? So 4 times 2 times 5, which is equal to 40. 40 sandwiches. I don't know why that reminds me of that line in Frozen when they read each other's, or they know each other's sandwiches or something. I don't know, something stupid. Okay. In how many ways can you arrange the letters of the word spring? And how many ways can you arrange just 2 of those letters? Well, let's do the first one. Arrange 6 letters in the word spring is just 6 factorial. Once you arrange, you've got 6 choices for the first one. Remove that letter, 5 choices, 4, 3, 2, 1. So that is basically 6 factorial, which is 720. But what if I want to arrange just 2 of the letters? Well, how many choices do I have for the first one? 6. How many choices do I have for the second one? 5. 6 times 5 is 30. So this is going to become really important because this is a true permutation. We have a subset of 2 out of the 6. Here we go. Yeah, this is a big mess. Let's cover that part up. Okay, a permutation is an arrangement. Okay, that's important because that means order is important. Double line that. Of a group of items. So the number of ways to arrange in order, n is our total amount, r is our subset. Okay, so it could look like this. P, n comma r, or n pr. I always use this one because that's what our calculator uses. So the formula is n factorial, that's your whole amount of letters, like the word spring you have, over n minus r. So r would be the subset. So in order to do P53 or 5P3, you're going to take 5 factorial over 5 minus 3 factorial. Well, 5 factorial is 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2. 2 factorial is 2 times 1. And these cancel. So 5 times 4 times 3 is 60. All right, to do 6P2, that's 6 factorial over, it's really hard to see, 6 minus 2 factorial. Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 2 factorial is 4 times 3 times 2 times 1, and those all cancel. So what do you have left? 6 times 5, which is 30. Alright, there is a way to do this in the calculator, especially like this one, okay? So first, you're going to go calculator, you're going to press 5, math, go over to PRB, go down to number 2, which is NPR, then you type in 3, then enter. Okay, so let me show you that on the calculator. Ooh, oh, that's not good. Okay, so 5. Oh, geez. Okay, why were we able to see it a second ago? 5. What if I go like this? I don't know. And then press math. Go over to PRB. The second one, you see NPR. Press enter. Then a 3, enter, 60. Okay, and then the last one, 3P3. So you have 3 factorial over 3 minus 3 factorial. Well, 3 factorial is 3 times 2 times 1. 3 minus 3 is 0. Factorial is 1. So that was up here. Okay, that's important. 3 times 2 times 1 is equal to 6. All right, what do you think? So far, so good? Next page. And there's not a lot going on here, so now let's apply these. A board of directors of Belford Community Hospital have 7 members, 3 officers, a president, a vice president, and a treasurer. Should this be a colon? Must be elected. How many different possible slates of officers are there? All right, let's think about it. So we have 7 choices for president. And then once the president's chosen, we have 6 choices for a VP because they can't hold the same office. And then once the VP is chosen, there are 5 people left to choose for treasurer. So 7 times 6 times 5. That's 210. Well, we're picking 3 out of the 7. So whenever you're going to be arranging a subset of a whole, so 7P3, that's 7 factorial over 7 minus 3 factorial. So 7 factorial is 7 times 6, 5, 4, 3, 2, 1 over 7 minus 3 is 4, 3, 2, 1. Those all cancel. 7 times 6 times 5 is 210. It's the same idea. So hopefully you understand this formula a little bit. You might understand a little bit more when we do combinations next section. All right, how about this one? A teacher has chosen 8 possible questions for an upcoming quiz. In how many different ways can 5 of the questions be chosen and arranged? Okay, so order is important here for numbers 1 to 5. Okay, because basically if you take problems 1 and 2 and switch them around, you have like a different quiz. I kind of debate that, but sometimes when I make a quiz, I do want to make sure that the material is somewhat in order of how I taught it. And also I try to make it so one question won't answer another one. So here we go. 8p5, that's 8 factorial over 8 minus 5 factorial. So 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. And 8 minus 5 is 3, 3, 2, 1. Multiply those values, that's what you get. Okay? Example 3. Oh, we're going to throw some probability in here. You ready? 10 students in your science class are given reports. See, you do something in science. On endangered animals. The order of the report is chosen at random. Find the probability that your report on the humpback whale is first and your friend's report on the American crocodile is second. I didn't realize American crocodile was endangered. In any case, 10p2, it's 10 factorial over 10 minus 2 factorial. So I have 10 times 9 times 8, I got lazy, times 1 all over. 10 minus 2 is 8 times 7 all the way down to 1. And these all cancel. So you just have 10 times 9 left, which is 90. All right, now, but they want, what's the probability that yours is first and your friend's is second? Well, there's only one way that can happen. So the probability that your first and second is one way out of how many different ways it can be arranged. That's going to pop up a lot. All right, find the probability that the reports were given in alphabetical order. Well, first of all, how many different ways can 10 reports be arranged? It's a big number, kind of looks familiar. I wonder if we did something like that prior. In any case, well, what's the probability that it's in ABC order? Well, there's only one way all of those can be in ABC order, so 1 over that big giant number. So we can actually write that number in the denominator on the bottom. Okay, now distinguish, well, permutations. This wasn't actually in your section, but I think it is important. So suppose you have a set of n objects, and n sub 1 of one kind, n sub 2 of another kind, etc. So, meaning, let's say, you wanted to arrange the words Mississippi, or the letters. Okay, well, how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11. And how many m's do I have? 1. How many i's do I have? 4. How many s's do I have? 4. And how many p's do I have? 2. So how you would do this one would be, you take n factorial, so that's 11 factorial over, then do all your individual parts. So I have a 1 factorial, 4 factorial, 4 factorial, 2 factorial. And then you'd work it out from there. Okay? So this is, you'll see this definitely when you get into high school. But I just wanted to put that in there. So let's go ahead and arrange the letters of mathematics. Not that eventful because there are 2 m's, 2 a's, and 2 t's. So there are 11 letters in this one, so we have 11 factorial over 2 m's, 2 a's, 2 t's, and then all your other letters are 1's. So find the value of 11 factorial. 2 factorial is 2 times 1 times 2 times 2, and then all times 1. So you get an 8 on the bottom. This is 1 factorial. I know it looks weird. And this is the answer you get. So 4,989,600. That's how many ways you can arrange the letters of mathematics. Because whether you arrange your m's, like the first m versus the second m, and swap, it doesn't matter. It's still the same letter. All right. So if you'll notice, we are at the end of this section. Here's our homework. Nothing eventful here, but you'll notice we're starting to hit more your standards. So because we're doing a little bit of everything here. Everyone have a nice evening, or actually a nice day. I've got to get dressed and get ready for our Wednesday class right before Easter. Take care. Bye.